Anesthesia management of bronchial lavage for the patient with alveolar proteinosis. In this video we will be focusing on the construction of the lavage circuit. This presentation assumes familiarity with the placement of double lumen endotracheal tubes, referred to from this point as DLTs, and you must have significant experience of both lung isolation and one lung ventilation. So a thorough grounding in thoracic anesthesia is essential to perform this procedure. While there are commercially available equipment sets for most surgical and anesthesia procedures, this condition is so rare that at time of writing the script for this presentation, there are no manufacturers making commercial sets for this procedure. So you may have to take this test on yourself. Many hospitals have cardiopulmonary bypass perfusionists who are extremely helpful in situations like this, and for them this circuit is very basic indeed. They can usually throw it together in a matter of minutes. You will need, however, to provide them with specific parts numbers or order numbers to ensure that all your components are compatible, and all this information is presented in this talk. In summary, the essence of this setup is a TUR irrigation system and drainage system and a Y piece, and this will be connected to the operative lumen on the double lumen tube. But if you don't have help from a perfusionist, you may have to do this entire setup yourself, and this video will help you. So, preparing the irrigation system for bronchial lavage. Construction of the irrigation system for bronchial lavage is simple, but it requires very careful attention to detail. The system is composed of 4 discrete components. The first 3 are best thought of as a distal component, a middle component, and a proximal component respectively, with the 4th component being a drainage system. Now, the distal section is a Y-type TUR transurethral resection irrigation kit. The middle section, this is essentially a Y junction, and this is a composite section made from 5 components. The proximal section, this is 1 lumen of the double lumen tube, which becomes the final part of the irrigation system. Essentially, the distal section is a TUR irrigation system which during the inflow or irrigation phase provides warm normal saline. The saline flows through a connector into the proximal section and arrives at the patient's lung. In the outflow or drainage phase, the cloudy saline will leave the proximal section, pass through the Y connector, and arrive in a drainage bucket below the level of the patient's lung. The key to success is that in the inflow or irrigation phase, the limb of the Y leading to the drainage bucket is closed, and in the outflow or drainage phase, the limb of the Y leading to the irrigation system is closed. Now, take an inventory to ensure that you have all the items you need before you start. I have found that cardiac perfusion techs are really very helpful and adept at constructing these circuits, but you will need to explain to them at least once how it all fits together. Here are the components you're going to need. commercially available kit, such as an epidural or spinal kit, or perhaps if your hospital makes their own, then you have a hospital packaged regional anesthesia kit may be used. These usually have everything you need, such as a sterile gown and gloves, and it's a convenient way for the anesthesiologist to set up a sterile work surface. Using full sterile technique, open the chosen kit on a Mayo stand where put on the sterile gown and gloves, place the plastic tray to one side, place sterile scissors and all the individual components that you will need on the Mayo stand. Maintain sterile technique throughout. Refer to the accompanied images. Open the pack with 1/4 inch PVC tubing, remove the yellow caps and keep these sterile for later use. This pack contains a white connector connected to 3 limbs of tubing. These are limbs A, B and C. Cut the tubing close to the white connector as shown to separate limbs B and C. Dispose of limb A and the white connector can attach to it. You are left with limb C, which is a simple long length of tubing, and a much shorter limb, which is limb B. Divide limb B into 2 lengths of tubing, each 4 inches long. These will be used as components for the middle section of the lavage circuit. Limb C of the 1/4 inch PVC tubing will be used as a drainage tube. Now, we're going to focus on the construction of the middle section. Take the following 5 components and connect them in series. First, the white connector. I'm going to refer to this as the central white connector from now on. Attach the 4-inch PVC tube to the bottom of the central white connector. Then attach the Luer lock straight connector, and then attach the second 4-inch length of PVC tubing, and finally attach the reducing connector at the end. This completes construction of the middle section of the lavage circuit. The 5 components are connected in the order shown. As an important note, the yellow cap, which was removed from the PVC tubing pack, is placed over the exposed end of the reducing connector to keep it sterile until it is inserted in the end of the appropriate lumen of the double lumen tube. Okay, now let's move on. We're going to talk about construction of the distal section. Now, take the white type TUR irrigation set, which constitutes the entire distal section, and connect the end to one limb of the central white connector as shown. At this point, the distal and the middle sections are now connected in series. The transurethral resection white piece, the TUR white piece, converges on a long length of tubing, most of which is redundant. Later, when you are no longer in sterile gown and gloves, the tubing may be coiled and taped as shown, just to make it easier to manage. It's a convenience measure. The proximal section of this lavage circuit is comprised of an accurately placed double lumen tube, which allows effective ventilation of the lung undergoing treatment. Remember, of course, if you cannot ventilate through it, you're never going to irrigate through it. The final component of the middle section, the reducing adapter, is specifically chosen because the 1/4 inch end fits snugly into the PVC tubing and the 5/8 inch end forms a snug fit into the lumen of the double lumen tube connector. Now, let's address constructing the drainage system. Limb C of the 1/4 inch PVC tubing will be used as a drainage tube which is attached to the remaining free limb of the central white connector. This is then led down to a drainage reservoir, a suction canister as shown, which is placed in a metal surgical bucket and is supported by a litre bag of IV fluid to prevent the unstable canister from toppling over. You just do not want the canister to topple because you want to ensure that there is a very visible fluid level, and you can tell when the canister is full or empty. The suction canister is a good choice because it can be placed in the canister holder of the suction apparatus, which is calibrated, and irrigation volumes may be conveniently measured in this fashion. You're not going to apply suction, but you can easily measure the volumes this way. The drainage limb of this system must be clamped while irrigating the lung in the inflow phase to prevent loss of irrigating fluid. The tubing of the distal section, that is the TUR irrigation system, must be clamped, and the drainage limb of this system must be unclamped during the outflow phase. This allows drainage fluid to leave the lung and flow into the drainage reservoir. But as an additional note, the arterial line setup is primed with fluid as is usual for making an arterial line, and it's connected to the Luer lock port on the straight connector so that we can monitor pressures during the lavages. This is important. The transducer for the arterial line is placed at the level of the midpoint of the lavage lung. It is open to atmosphere and the pressure is 0 to 1 atmosphere pressure. During each lavage, while the lung is full of ergon fluid, the surgical team will percuss the lung briskly and effectively, and this is part of vigorous physical therapy to loosen up the secretions. The anesthesia team will alternatively rotate the patient's position between head up and head down at left lateral and right lateral tilt to try to disperse the ergon fluid to all parts of the lung. Each full drainage canister is kept and inspected for gradual but obvious clearing of the drainage ergon solution, and this will hopefully provide evidence for complete removal of the lung's burden of abnormal protein. Thank you for watching this video. I hope it helps. Of course, this is the way we construct our bronchial lavage circuit. There are many different ways to do this. But for those of you faced with anesthetizing a patient with this condition and you've never done it before, this is safe and effective, and I can recommend it to you. But you may, of course, be able to come up with your own circuit of your own design, as long as it is well thought through and carefully designed. I'm sure it will also be safe and effective. Anyway, thank you very much for listening to my presentation. I hope it helps you improve the care you provide to your future patients with alveolar proteinosis. Thank you for watching.